Good afternoon. Today we'll be talking about mastication and degluttition. Human masticatory system is a combination of kinematics and mechanics, which is based mainly on class 3 liver function test, which wherein the fulcrum is located at the articular eminence of the TMJ. The main basic segments are the mandible and the skull, which is mutually linked by the temporomandibular joint. Masticatory system composed of teeth supporting structures, jaws, TMJ, muscles of mastication, vascular and the nervous system, which acts as the functional unit. Mastication, it is action of breaking down of food to prepare the food for swallowing and is the first step of digestion. Chewing, it is roughly called, acts in breaking down the food into form a bolus. It is a complex neurophysiological activity. The most important mandibular movements is the masticatory movement, which is based on the stromatognathous system. The objective of mastication is to crush, triturate, and mix the food with saliva, and then it is transported by deglutition down the digestive canal. The significance of mastication includes breakdown of foodstuff into smaller particles, mixing of saliva with food substances, lubrication and masking of dry food, formation of bolus, taste sensation. Mastication sequence includes the number of chewing cycles that extends from ingestion to swallowing. This forms the preparatory series of movements, the cycles of particle reduction and the cycles related to pre-swallowing. It depends on differences in the type, number, and the size of the food. These are the masticatory parameters. The duration of each chewing cycle is approximately 700 milliseconds, and duration of the tooth contact is approximately 200 milliseconds. Now, it is to be noted that masticatory sequence is short for soft foods and long for harder foods. Masticatory sequence is a chewing pattern which is of a teardrop shape pattern, wherein the mandible travels in a teardrop pattern. First, straight, that is the opening of the mandible, then later a convexity or a bulge towards the chewing side. The chewing cycle consists of 6 phases: preparatory, food contact, crushing, phase of tooth contact, grinding, and centric occlusion phase. The role of the tongue in mastication. This, especially in the preparatory stage, the tongue prepares for food reception. It forms a trough-like area to collect the food and forms a pocket formation at the tip, and which contacts with the lip so that the solid matter can be taken inside. The throwing stage, wherein the anterior part of the tongue twists over on one side and the dorsum part faces the lingual surface of the teeth. This sudden movement throws the ingesta on the surface of the lower grinding teeth so that you can chew it properly. The grinding stage, the tongue retains twisted portion and the dorsum presses on the medial side of the grinding teeth. It prevents the food from slipping into the buccal cavity. The tongue, the buccinator muscles, they act to keep the food between the grinding teeth and prevent its escape. The teeth cuts and grinds the ingesta taken inside. This is the grinding stage. Sorting out stage begins at the completion of the series. The grinding teeth are separated and the buccinator muscle pushes the food in buccal cavity and onto the tongue. The tongue movement is rapid and jerky and sorts out larger particles that is placed on the middle in the trough-like area, and these parts already crushed are placed laterally. This movement is continuously repeated to form the correct bolus formation. Stage of bolus formation, it partly overlaps the last stage. The tongue makes an alternate side-to-side churning movement and it mixes the crushed food with saliva to coat it with mucus and makes it into bolus that is ready for further swallowing down. This is the stage of bolus formation. Now, the role of TMJ in mastication. It allows 3 basic movements: a hinge-like movement, a protrusion and retrusion movement, and lateral movement. The condyles in mastication helps in the chewing side, which is there is a condylar displacement which is greater on the chewing side than on the non-chewing side. This condyles presses against the mandibular fossa, and the range of condylar motion on the chewing side is less than that of the non-chewing side. Condylar motion, there is three opening motions. Opening initially, that is in the superior direction. Closing initially, that is in the medial direction. And closing at later stages, that is in the posterior direction. Now, you know the movement of the TMJ. You have already studied in temporomandibular joint chapter. Now, the muscles involved in mastication. The concern with opening of the mouth, especially the lateral pterygoid, and closing of the mouth is involved with temporalis masseter and medial pterygoid. Certain accessory muscles like digastric, geniohyoid, mylohyoid, and buccinator acts as the accessory muscles involved in mastication. It's the temporalis muscle, then you have the medial pterygoid, the lateral pterygoid, the masseter, and the buccinator muscles. Hard palate in mastication, it acts as a surface where the tongue presses against the hard palate to help in the masticatory movement. It is sensitive to touch and detects the harsh food substances. Loss of taste sensation in denture wearers is due to the loss of touch sensation and reduced ability to judge the texture and the temperature of the food. The lips in mastication, it's partly sensory and is sensitive to touch and temperature, prevents the entry of unpalatable material. Mechanical function is to transfer the food and helps in prevents the loss of food from the mouth during mastication. Occlusal contact and mastication, the proportion of masticatory strokes varies with different types of food. In general, half the masticatory strokes led to the occlusal contact. The contact frequency increases and the food is broken down constantly. Chewing tends to be unilateral. On the chewing, contact is on the chewing side, non-chewing side basically. The chewing time differs for different types of food. Proximal contact resists the separation and prevents the food impaction. Neurological control. There are sensory receptors which helps to receive the inputs by CNS through different afferent fibers. Chewing is a subconscious activity and can be brought to control at any time. There is a coordination and rhythmicity of mastication that has an alternate activation of two reflexes, jaw opening and jaw closing. Jaw opening is activated by tooth pressure and tactile stimulation. Jaw closing is activated by stretching of the elevated muscles through the opening phase. Now, brain stem is a central pattern generator area which controls the rhythmic activities. Now, control of mastication is dependent on mechanoreceptor afferents, periodontal afferents, TMJ afferents, and muscle afferents. Now, biomechanics of masticatory forces includes the muscular and the reaction forces. The active tensions changes with length and shortening of the muscles, and passive tension increases when the muscles are stretched beyond the optimal lengths. That helps in jaw opening and jaw closing. The masticatory bite force, the active tensions of the jaw opening and closing muscles produces strains, and the functional bite forces, the masticatory force acting upon the plane called the occlusal surfaces. The static bite force ranges from 100 to 1000 newtons, and the dynamic bite force ranges from 3.5 to 350 newtons. The force exerted is measured through a nathodynamometer, wherein the anterior segment is approximately 60 kgs and above, posterior segment up to 90 kgs and above, and each tooth bears about 6 kgs and above of load. The force exerted by tooth in individuals differs from the incisors can bear up to 11 to 25 kgs and molars from 29 to 30 kgs of forces. Now, the periodontal ligament has its biomechanic activity. Neuromuscular system, they regulate and control the biting force not to exceed the critical limit of load bearing the capacity of the PDL. The direction of occlusal load is important. The forces in axial direction is better withstood. Force in axial direction is better withstood than the horizontal forces, which is not tolerated because of the bending of the tooth that creates a compressive and tensile stress. The forces from the antagonistic teeth exerts on the opposite arch through bolus, and this is deviated in different directions, which is transmitted by the periodontal ligament and adjacent teeth structures. Now, this is the vertical component over here, and this is the horizontal component. So we know that the vertical or the occlusal forces are tolerated much better, which is intruded into the alveolus. And horizontal component of forces, the primary causes mesial dislocation of the adjacent structures. Measurement of masticatory forces is done by is called nathodynamics, It is a study of relationship of the magnitude and direction of forces involved in mastication. It is measured by nathodynamometers, and the bite is measured as force and not as stress. This is a nathodynamometer. Now, most complex reflex elicited by nervous system is mastication and degluttation. Involving cranial motor nerve nuclei and coordination of various muscle groups, degluttation or swallowing is a reflex with sequence of muscle contractions. It is an orderly physiological process and transports ingested material and saliva from the mouth to the stomach smoothly and effortlessly to execute and orchestrate the swallowing sequence. Rate of swallowing is approximately 1 per minute in aquatic subjects without conscious input between the meals. High swallowing rate is initiated by some swallows are voluntary. During wakefulness, 600 to 2000 swallows are done per day, and it increases during eating and nearly ceases during sleep. Now, anatomical components that helps in swallowing or deglutition are bony and cartilaginous support, muscular components, and neural elements. Bony and cartilaginous components, the maxillary palatal arch, they oppose the tongue and act as a surface against which the tongue works. The mandible, they has a hinge-like movement. Basi-occiput, they have a pharyngobasilar fascia that originates from the basi-occiput, which anchors the pharynx to the base. The cervical spine, which is firm and flexible, supports the pharynx, and membranous planes allows free axial movement. The hyoid bone, intermediate supporting structure for the larynx, acts as a platform for the tongue, and thyroid membrane muscles attaches to the larynx to the hyoid. The larynx forms the anterior wall of the hypopharynx. Epiglottis, it acts as a ledge to prevent the entry of food into the larynx. The sides of the epiglottis, they form a chute from which the bolus enters the food channel, and it acts as a cover to prevent the food from being sucked in the airway if the larynx is open. Now, the muscular muscles that is innovated and innovation that helps in deglutition are muscles of mastication by the trigeminal nerve, facial muscles innervated by facial nerve, muscles of the tongue innervated by hypoglossin and ansa cervicalis, muscles of the soft palate by vagus, muscles of pharynx by vagus and staphylopharageus and glossopharyngeal nerve, muscles of larynx by vagus, recurrent and vagal and superior laryngeal, suprahyoid and infrahyoid by the trigeminal and the facial nerve and ansa cervicalis. Neural elements, there are efferent motor fibers contained in the cranial nerves and the ansa cervicalis, afferent fibers contained in the cranial nerves, cerebral and the midbrain and swallowing centers. There are paired swallowing centers present that helps in the deglutition process. Phases of swallowing. First is the oral phase, which is the initial phase wherein the tip of the tongue raised and pressed against the posterior surface of the incisors and the hard palate provides a complete labial seal. The rare closure of the soft palate occurs and prevents the escape of the ingesta into the pharynx. The soft palate descends into the lingual dorsum. Infusing muscles of the tongue helps in this process. The hyoid bone is moved upwards and forwards, and post-cervical part of the tongue is drawn up and back. The palatal glossal arch is approximated together to form the oral phase. Second stage of swallowing is involuntary. For liquids, the lingual muscles, they squirt the liquids backwards and mylohyoid contracts, and so that we can gulp down the liquids. For solids, only the mylohyoid muscles action is needed. The food is propelled past the anterior fascial arches. Anatomic reflex gesture of swallowing is triggered and peristaltic reflex sequence is initiated. Second is the pharyngeal phase, which is the triggering of the peristaltic reflex. The bolus is passed through the pharynx into the esophagus and produces a peristaltic wave. 4 main stages are there. The ingesta is prevented from entering the nasal cavity first. The bolus is transferred from the fascial arches through the pharynx into the esophagus, and ingesta is prevented from entering the tracheal part. The soft palate is elevated, triggered, tightened, and firmly approximated to posterior pharyngeal sphincter and upper part of the superior constrictor pharynx, and pharyngeal isthmus is closed tightly. Larynx and pharynx are drawn up behind the hyoid bone and forms the aryepiglottic folds, which is approximated, and this excludes the bolus from the larynx. The bolus slips over the epiglottis and closed laryngeal inlet is done. The passage is facilitated The passage is facilitated by palatopharyngeal muscles and makes the posterior pharyngeal wall into inclined plane so that the bolus can slide down. Aryepiglottic folds, they provide lateral channels. These provide the lateral channels leading from the epiglottis to the esophagus, and the bolus descends down the esophagus. This is the pharyngeal phase. Then we have the esophageal phase, wherein the bolus is transferred in the continuation with the help of peristaltic wave, with the help of cricopharyngeal and gastropharyngeal junction, until the entrance of the stomach. Three different forces act: the momentum generated by the contraction, the gravity, and esophageal peristalsis. Expulsion of bolus takes place and liquids flow by gravity ahead of the peristaltic wave. Solids pass along with the peristaltic wave and velocity is approximately 2.4 centimeters per second. This is the time taken for all the four phases. Oral and pharyngeal phases, it is 1 to 1.5 seconds. For oral phase alone, it is 0.5 seconds. Pharyngeal, it is 0.7 seconds. And esophageal phase is 5 to 9 seconds. Thank you.